Hello, everyone. In this video, we're talking with Andreas Angourakis about his model, the Indus Village's weather model, a procedural generation of daily weather. Thanks for joining me.
Thank you, Shan. I'm very glad to be here and to answer the Coms's questions.
Okay, well, let's start with the purpose of your model. What is the purpose of your model?
Okay, yeah. So it's in kind of the name in the sense of like, okay, it's a model that is focused on generating weather patterns. It's not a climate model, so people that might read that has a generation of whole climate system, so it's not. And it's really trying to actually prioritize the computational efficiency instead of actually representing the whole mechanism behind it. And it's the purpose of the design itself is actually to complement socioecological systems, so the simulation of socioecological systems. So basically, no, you don't take the resources out of social or ecological phenomena, and you just use that kind of module to solve that part.
Okay, so this is sort of a backbone to other simulation model work. Yeah.
Yeah. Yeah, it really depends on the model itself. So in our case, was really centered in agriculture, in the Indus Valley civilization. So basically, the question was not quite only the weather, but the weather or the climate actually had a big component in that side. And we also didn't quite have the full data set, at least not, well, not really now, but also not in that time, even less. So even though you have proxies, etc., you couldn't really reconstruct the daily data that you need for this kind of simulation of crops, for example.
Mhm.
So basically, we just needed something to complement it, but still within the realm of feasible or realistic in the sense of following the same patterns. Yeah. So,
Yeah.
so the seasonality is an important point in this purpose because most of models that are applying archaeology or long, like deep time, they are really more focused on no like very aggregate indicators. So the average, sometimes the maximum, minimum, but really looking towards no very aggregate patterns. And the seasonality kind of gets loose in between. There are works with seasonality, approaching through proxies, but in any case, for simulation modeling, we just needed something a bit more, well, easy to connect with the rest of the model. So we just needed a few variables there, but those variables had to have this kind of daily iteration. Yeah, this was kind of the key of it. And the development of this model was really pushed by this kind of necessity, was like very pragmatic necessity. So I'm not at all a climate or like someone that is into weather or climate science. So it's really I had to look at that from the kind of perspective of trying to do a socio-ecological model. And my background, of course, also not even in natural sciences properly. So I had to really look into is it how many models there are out there, how many kind of a variety of approaches, is that approach feasible for us or not? So I had to kind of well have a kind of literature review, but also probably incomplete. So I'm so sure that this was incomplete. But in any case, I really saw that either you go crazy with parameters. So basically, there are models that no, based like you have a probability, for example, for precipitation, you might have a probability distribution for each day of the year, and just simulate the pattern from there. So you say, okay, you need actually 365 parameters in the model. So it's like, okay, this is a bit crazy. It's just fitting the curve. And it is useful, of course, in certain contexts, but for our kind of simulation would be just crazy. And the other extreme of it also was, well, the other extreme not, but kind of the approach that normally is adopted in archaeological cases is really just to use directly either proxy data or use the kind of like generated by climate models, for example. No?
Hmm.
So you have actually proper models even spatial models, just giving you the data and then you use it. And our problem, or at least my concern on it, was the basically like the overfitting, in the sense of you don't know quite well if the response of your model will be actually changing if you know you change or have very small different details on the data set. And in our case, because we're also looking to very local scale, it actually matters. So, you know, if you get a data set from one point, even if it's empirical, yeah, who knows if that data is actually representative, you know, or what we're actually aiming for. So the model was actually a response for that, and yeah,
Yeah.
it took a few years to develop, so fully and publish, but at the end was worth it, I think.
Yeah. Um, I mean, in some ways, it seems like your model is, or this is designed to meet a challenge as opposed to it being, I mean, it's challenging, I'm sure, to create so much climate data is so coarse and on like 1,000-year time scales, especially when you try and look at climate data in the past. So getting it down to, did you say the daily? Is that
Yeah,
how
it's a
fine it gets
daily
down?
because yeah, the other side of that is the actually my modeling trajectory within this Turing project, the ERC Turing project. Sorry, I did also mention, but all of this is in the context of this is a consolidator project back in so we ended already in 21, so it's a few years ago already. Um, and this project, so sorry, I probably need to mention also the PI is Cameron Petrie from Cambridge, from the University of Cambridge. So thanks to him, actually, that I was actually doing that. Um, and the root of it was that we started looking into crop models, or I started really looking into crop models, which is a whole community also. No, you probably know,
Mhm.
Sean. So, and he has a lot of models, very standard models, whole communities built on models. And I had a look on, well, several, even up to the detail of code and kind of data sheets for crops, for example, know how they actually parameterize that. And I was just finding that, yeah, was really either plug and play and see what happens, or I could not really explore the hypothesis from the archaeological side. So, for example, one of them was about multi-cropping. So how important was multi-crop in the past? If that entail a change, that like a change in climate entail a change on that strategy. And all of these, of course, if you try to do multi-cropping, those models, yeah, some of them you literally need to kind of simulate that crop every time with a lot of data and then get the data set frozen, like, and somehow use with your model. So it was just too complicated, the workflow, and also, in my opinion, was not robust enough in terms of the result. So you say, what can I actually say about that? So then after that, and looking into those models, I found a simple model. It was literally called simple model, crop model. One paper. So it was really like this kind of luck. And the model, of course, is simplistic. It has caveats, but it was a model that actually allows us to assess this, yeah, the idea of having multiple crops and parameterizing them in a reasonable way that you can actually add more complexity to the model. And through that model, I already realized that yeah, there was no good model of Chrome model that just used one value, for example, precipitation the year. No, there was not good enough approximation, and for sure not for once you are taking into account the seasonality or different crops with different seasons. No, so all this complexity was kind of just lost if you try to match harvest with the average rainfall, for example, mean or total, etc. So all those aggregates are not enough. So yeah, that was the main motivation, kind of the red line that I had to put into myself is say, okay, it needs to be daily. If it's not daily, it's just not yeah, it's not working with that rest of the mod.
Yeah. Yeah, I've had some projects in the past that I was part of that did try and that did sort of didn't do what you did, which I I thought was always a weakness, which it's just said, okay, there's 400 millimeters of rain in this location, so that means we get this much wheat, and just, and it stopped
Mm.
there. And that
Uh,
doesn't allow you to ask sort of the interesting questions. And it doesn't really simulate human decisions, which are, on a much smaller time scale than annual. And so, so
well,
could you tell me some of the sort of the insights coming out of the model? You sort of sketched a little bit of them already, but
Yeah, I mean, because as you say before, the model is actually not in itself, no, in terms of doesn't respond the research question in itself, even though we actually could extract some ideas from it, already has a, well, at least understand better even the actual weather that we are aiming for. So the particularity of the case study there on the Indus Valley, or at least the region of the Indus Valley we're looking, was this so the project was two rain, so basically it was because there was two raining seasons, which is not the most common pattern around the planet. You actually no more normally have one season for rain, but or at least no season at all is even more common. But in that case we have this complication. So and it's a complication in the sense that if you have two types of crops already that they are no in different seasons, but actually there was three because there's in India that you have like a moment that actually you can cultivate certain crops and not others. So you really have three groups of crops. And with this model, the results actually allow us to just now generate and contrast the parameters. So the parameters are more or less interpretable. So they are not like, for example, that kind of massive kind of model where you have so many parameters and most of them are like almost, so they are interpretable, but they are really just reduced. No, so in that case, we could say there is a parameter that determines when is the moment. So sorry, the moment where you reach the half of the cumulative precipitation. So basically, if you, I can perhaps now share the and show in the paper is a bit easier.
sure.
Um, okay, so this is I just open also in the concepts, but have here in the figure. So this is actually the data. So it's data. It's not particularly, so it's not fully empirical because it's from this NASA Power. Yeah, basically they kind of have a web interface that kind of aggregate data together. So it's not necessarily even from the same source, but and part of it is based on already in climate models, but they are no as good as it gets in terms of pinpointing certain kind of information.
Yeah.
And and here, let me just increase the whole thing a bit more. Um, so you can see already that the cumulative precipitation throughout the year, you can really find different patterns. And in some cases, you actually have those plateaus in the middle. And those plateaus are parameterized in the model. So basically, looking at the data, I just search for ways of kind of. So first, I search how to model the actual daily precipitation, which is crazy. In the paper, if people look at it, there are some arguments or like explanation of how complicated it can be to do that. Just has data, it's not even thinking about the actual precipitation. But then the cumulative annual precipitation is actually much easier because it makes kind of a logistic curve almost. And in the case of the Hakigari here, you don't quite see, but in the bottom, can you see my mouse?
Yeah.
Yeah, the
Yeah.
cursor. Okay. So in the bottom here, you have like a first step on the curve. And that first step is actually the first season because it's kind of falling in the early, well, in the late in winter. No, so basically you have a squish there. It's not so perceptible than the other one, which is the monsoon.
Yeah.
So that big one here is the monsoon. But you do have the two. So and then you have the plateau here towards the middle, and you have certain variability when here is in Windhoek in Namibia, you have this kind of big plateau, which is kind of the dry season. Um, and and that's kind of just clicked to me to say, okay, then I can actually model these and then reconstruct the whole pattern, or at least using stochasticity as an ally on that to generate the precipitation, so the actual volume of precipitation. Um, so the insights here was really that towards the end we kind of understand a bit better that patterns or the pattern also in relation between. So you had several conversations with me and the climate scientists of the group and the PI, so Cameron Petrie. We were really just thinking about what those things actually mean, for the human decisions, or even also with the archaeobotanist collaborating the project, also about how that actually fits with the cropping schedule throughout the year. So the kind of basically once you can get this reproducibility of the weather pattern and not just based on data, which is nice, but at the end of the day, yeah, you have 20 years, so this is uh, you can see here. So this is a span of time. You have,
Mhm.
of course, yeah, potentially it is similar, potentially. So hopefully, of course, the pattern is similar to the Bronze Age period in the region, but in other cases it might not be, or in other cases, yeah, you cannot just fit up to a few years of data and hope that that is kind of making sense for your model. Um, I have another, sorry. So towards, so basically here you can actually understand what I'm saying, that you understand a bit better the actual weather pattern by just manipulating the model, the parameters, and you realize certain things. And I think that is actually helpful once you're trying to find um, proxies for actually calibrating that model. And here you have an example of the one used for temperature and solar radiation, which is basically a sinusoidal curve, that sinusoid that just gets modified by noise, uh, and it kind of fit well. So that was actually surprising how well it fits in terms of course, it doesn't fit perfectly because you have other things affecting, especially
Sure.
solar radiation. You have like the cloud cover, etc. We didn't integrate that because it creates feedback loops, so really complicates a bit the model. But you can see that using the parameters, you can kind of think about, so what does it mean that in that place you can kind of reproduce the pattern without so much fluctuation? What does it mean if the maximum minimum is far away? So all those kind of reflections on the model you can actually relate to known climate and weather patterns, or knowledge really. Um, and in terms of so here is just a comparison that we had with that data and simulated, trying to, so after a certain calibration process of the parameters, looking into that data. And you see that, yeah, basically we do have, so we comment in the paper the issues of discrepancy, and there are issues. So this model is not perfect in terms of reproducing the pattern, but it really helps to understand more kind of consciously. Now, if you use this model for that thing, what is the big difference in real data that you might encounter? No, so for example, if you are in Ireland, but perhaps you need to look into the cloud cover shore. If you are in other places, perhaps not, etc. No, so you have this phenomenon. In Rakigari, ironically or not, we do have some issue here because of the monsoon creates so much effects. You can see the solar radiation is much more diffuse, and also the temperature has this kind of kind of lagging of the curve. So all those things means more about the calibration and then adding a few extra mechanisms behind it so you can actually tune that pattern. But yeah, for the plant, so if you're actually doing four-crop modeling, that part at least is not so vital. So it's much more vital the fact that you have the precipitation pattern more or less. So when it arrives, the rain is important. All this kind of small details is more important than than the other kind of models, the small details. Sorry that I'm being a bit complicated with that. Um, yeah, but in terms of, yeah, I mean, the insights of the piece itself, of the model itself, by it's not, I would not say or not call it as a research insight. Is more about, well, it is a research input, but it's much more methodological insight, I would say. Um, yeah, I mean, as you put before, the case where you actually have an option. So can you stop for now sharing? When you actually have an option for going for more complicated or less complicated, or no, or trust the data or not trust the data, I think you, at least this allows you to kind of have a tryout. And if you realize, okay, if I use that kind of model and everything is like kind of the same result that I get with the data, okay, maybe you can just go with the data. It's easier. You don't need to trust the model itself, but the model really helps you to know if you do sensitivity analysis in your other part of the model, you then realize very easily what might happen or not if the weather changes. No, so this is
Yeah.
kind of a big advantage, I think.
Yeah. Do you so this was part of the Indus village model, right? The you used it for that. It do you have any plans I guess would it be possible for somebody to adapt your model to a different region, or do you have any plans to do anything like that?
Well, yes, even though with the because this model is really connecting with that crop aspect. For now, I didn't use because I really need some backup in terms of someone with knowledge about the case study in terms of the plants, the crops. So this is a bit more challenging to just try it by myself or try more casually with collaborations. But I so the whole design of it's made for being modular. So the whole Indus village setup uh, has been taking very much many years than like way more years than the actual project that is started. But I just don't quit because yeah, at the end, each part is taking me extra work. But I have been trying to do at least, for example, net logo and what I can do in R, for example, not in Python because I think that is yeah, it's a bit too challenging for one person to do, but also in terms of if you do R, you probably will be able to, between R and logo, find out a version in Python. But the intention is that each module of that framework is reusable for other purposes. So it's not even, as long as you need those variables that are basically the main output of the module, um, it can be useful. So you can do, for example, focusing a model on inundations in a urban environment, no? So in the urban setting. So you can actually use that model to just have the weather and the precipitation. So even if you don't have transpiration, because I don't know, it's just about rain falling at some point or
Mhm.
during the year, so you can kind of, yeah, even use parts of that model. So precipitation, temperature, all of this is quite modular in the code itself. It can be reused more or less easily. Um, and yeah, and I have been developing, as I say, the Indus village framework still is in GitHub, and it has two kind of versions because I have been keeping together with the team there. I started this kind of organization in GitHub with the two Rains project itself. But right now I'm actually developing more in mine, and I'll eventually do kind of the synchronization and release from there just to have like the clear two rings framework. But there you can see, so now I can share again. So I have opened this. So in the repository, you actually will see there is the weathers, the kind of the first one. Each folder here is like basically one module. And it's not even all of them around here. So there are a few modules that I am kind of still processing. So it is almost there, but it's not quite. And you have this initial folder, which is kind of the integrated models we have been building up with those modules for the Two Rains project. Um and actually one other paper we published before that weather model. So it's kind of ironically because we actually use the weather model, is doing the whole, so it's showing the integration of crop modeling and the weather model and a land. So there is also a land model, which is uses also the procedure generation for having different terrains.
Hmm.
And right now I'm actually working. Hopefully, I will be submitting soon because I'm past the deadlines of the demographic model. So the model that is really focusing in a very modular way of representing population dynamics, uh, where so it's kind of the same philosophy. So not going all the way into complexity, but also not simplifying too much. So the whole approach here is that Asians are households, which is kind of the normal thing. No, in
Hmm.
ABM, it's not so common, at least in these kind of models where you represent individuals as Asians. But here we do account for each individual, at least in those variables that are relevant to the model. So age, sex, the marital status, the lineage. So there is a tracking of lineage. So all those things, but I had to, yeah, I just added, yeah, you know, probably that there is always this fever when you do models that the, no, the, you
Yeah.
start imagining the whole world and you want to add it. So I control myself, but I'm also not, yeah, I'm not in the spectrum of the keys people. No, in the sense I'm not so affirmative of saying just keep it simple.
Yeah.
uh, be, and actually, I separated a few images because I thought that this is an important point. So I have here every time someone says, "Oh, but this is so complicated, it's not worth it," and I think, look at this. This is like, I'm sorry that I probably will send to you like the actual from who is this image, but I think it's in Wiki Commons.
Okay.
Um, and I always think, okay, yeah, things are complicated. We all know that. We know that modules cannot be the same thing. That's for sure. But we also know that we are actually capable of a lot of things in terms of modeling, especially right now. So why we should keep the model simple always, if we actually know that this no passing the mark in terms of certain
Sure.
levels of complexity. So here's the no the metabolic. Oh, this is like a kind of a jokey thing. It's the metro map, so it's kind of trying to represent it as a metro circulation. But I don't know if you have any kind of background in this kind of biology, if you kind of know what is, well, probably some of things are very famous here, but basically everyone that does this kind of metabolic cycles are really, they know that's very complex and you never tell them, oh, you just basically transform sugar into energy and that's it. No, so you never, you cannot never simplify their minds about it. No, so and I have another one. Just this one is even pixelated because it's so big.
Oh,
I
yeah.
couldn't download. So you can realize that things, and this is like cellular level, no biology. So it's really like if you think about it, uh, things are complicated. But someone actually studied and is able to map it. So even if it's probably not a perfect model, no, but this is just a point that I'm always thinking about, well, especially in the ABM community, that you have the two spectrums perhaps in the same community, and also this criticism from the community,
Yeah.
um, where yeah, basically other people just say, "Why you're doing ABM if you can do just one equation and find the same result?" No, so it's never so simple. The Yeah, sorry, I will just stop
Yeah.
sharing so you have my
My answer
face.
to that criticism is always emergence and geography, right? Like, you know, humans have emerging complexity and social systems that I, I think a differential equation isn't going to capture. And yeah, that we live on a landscape that isn't predictable and isn't uniform. And so, yeah, I think agent-based modeling does a great job of combining those things in there. So I like your argument of making models more complex.
Because in my mind is actually going even further than what you're saying because it's saying it's actually it's not only about us being social beings or having this no this self attributed complexity that we because we know it ourselves better. No, you. But when once you apply to almost everything, no, it's the complex system kind of perspective that it's basically everything. It can be quite complex, and the complexity is important because you have emergency, you have no aspects that cannot be explained or even kind of just understood, even if it can be kind of explained statistically. No, it's not explained in terms of yeah, knowledge. No, so you don't
Yeah.
really know about it once you if you don't really model it at some level. No? Yeah, so basically all of this long argument was about so the Indus village model, it's relatively complex in terms of parts, but and it's very slow in developing because fortunately I have been working alone in terms of as a modeler, but it's really I think it's worth it once one of those modules is done well documented, etc. I think it's the philosophy of Comtes behind it, also the fact that you everyone could do a model and publish a paper and forget about it if it doesn't have any documentation. The code is nowhere to be seen.
Yeah.
uh, like I review some papers, for example, that doesn't have any, not even a mention of sensitivity analysis, which you say, and sometimes it's a quite complex model, and you say, yeah, I was in the other end at some point in my career, but you realize that this culture, for 10 years, it has been going on and it still didn't catch up. There's a lot of papers being published with not enough on the model itself. No?
Yeah.
So
Yeah, I mean that's what's great about your model too, is not only, that it's not COMSIS, but it also, uh, people, even if they're not going to do daily precipitation in Indus Valley, they can still build off of what you've done. And I think the other thing that people like to say is scaffolding, right? So you can just constantly like build on the work of others, and so that we're not reinventing, you know, this type of code. So.
yeah.
Well, thank you for taking the time to talk with me today about your model. And if anyone would like to try out Andreas's model, the link will be available in the description, in addition to the link to the article that you showed us, and probably the GitHub one as well. So there's a lot of great information out there.
And I'm open for contributors in GitHub. So if someone wants to actually help with any of those modules, yeah.
Yeah, that's great.
Okay.
Well, thank you very much.
Thank you, Sean. Thank you. Thank you.